We've been looking at conic sections in this class. We've gotten through hyperbolas and not hyperbolas, that's what we're looking at today. We've gotten through parabolas, looking at parabolas in a special form, left, right, looking at focus and directrix, graphing those. Then we looked at ellipses and special terminology for ellipses, the major axis, the minor axis, your vertices, the foci. And now we're going to look at hyperbolas. And so we had talked about all these conic sections were shapes that we could get by looking at a right circular cone and making slices of these. So let me go through and give you the definition or a definition of a hyperbola. And then let's go through, let me give you all the kind of terminology, and then we'll go through and look at some examples. Okay, so a hyperbola is a set of all points such that the difference between the distance of two focal points is a constant. Okay, so notice here we have two hyperbolas, not two, we have a hyperbola, and I think of them kind of like parabola shapes, but my husband doesn't like me saying that as a mathematician. But to me, they're like two parabola shapes that are facing away from each other. And this is the parabola shapes to me are going towards the x-axis, but they could be going towards the y-axis, facing towards. So let's look at this. So notice that we have two foci, and the hyperbola is going towards that foci. And it's telling me in this definition that if I look at the distance between the foci and a point on my graph, and I look at the difference between the longer distance and the shorter distance, it's always going to give me that same constant C. You really don't need to know that to get this information to graph these. Okay, so let's now look at the following. So here is our hyperbola. There's lots of different things going on. And so looking at this, we have our foci. We have our vertices. In here, we have two axes. We have this axis right in here that's joining the two vertices. That is called the transverse axis. This halfway point between the vertices, right in here, that is the center of our hyperbola. So the transverse axis is really helpful, but this conjugate axis is going to help us draw these asymptotes. And so this conjugate axis is this line right in here. What we're going to try to do is we're going to make a box. So we're going to go out here and basically a box from these axes. And from those boxes, from these axes, we can draw a line that goes through the corners and the center. And these are called our asymptotes of our hyperbola. Okay, so let me give you what this looks like in standard form. So if we were going and facing towards the x-axis, then we have the following. And it almost looks exactly like a ellipse, but I'll show you the difference in here. So we have x minus h quantity squared all over a squared minus y minus k quantity squared all over b squared. This is equal to 1. Again, this is if our hyperbola shape looks like this. In here, we have our center. So just like with a circle and the ellipse, it's the opposite signs. So our center here is at HK. And then to get our foci, actually before the foci, let's look at the vertices. And the transverse axis, or on the transverse axis. So these are these points right in here. We have our center here at HK. The distance between the center and the vertice on the transverse axis, this length in here is A. So we're just going to do the same thing that we were doing here when we were looking at defining how to get these points. My graph is a little off. That should be horizontal. And so if that's horizontal there, then from the center, we're going over A to the left and over A to the right. And so that's affecting the X value of our point of the center. So if that's affecting the X value, we're adding A and subtracting A from the X value from the center. And so here we would have H plus A, comma K, and H minus A, comma K. The vertices on the conjugate axis, so these points up in here, our X value is staying the same, but it's our Y value that is changing. And we can get this point, X value is the same of our center, so H, and now we're adding either B or subtracting B from K to get those points. The length of the transverse axis is 2A, and the length of the conjugate axis is 2B. Okay, so this is just if it's facing towards the x-axis. If our hyperbola shape was facing towards the y-axis, then it's a little different. So if it looks similar to this. The standard form of this is going to be y minus k quantity squared all over a squared minus x minus h quantity squared all over b squared is equal to 1. Excuse me. So looking at this, we can see that the center, again, h is always with the x value, opposite sign. So our center is at hk. So remember when the ellipse, I told you that the a value and the number in the denominator that was larger was always a. that, and I told you that don't get caught up in that with the hyperbola, because that's not the same. Hyperbola, when we're looking at this, the a value is always with the fraction that is positive out front. So notice that one of these, each of these have a minus sign. And so a is with that fraction that's with the positive in front, and b is in the denominator where the minus is in front. So a is not necessarily bigger than b. C squared, and that's different too for an ellipse. We had c squared was equal to a larger one, a squared minus b squared, but a is not always larger. C squared is equal to a squared plus b squared. So I forgot on here about the foci for that first one. So the foci, right? Those foci are these points in here that that parabola shape is facing. And so this foci we can get to by adding or subtracting c from the x value from our center. So h plus or minus c comma k is another way to write it. Okay, so let's look at the foci, since we just talked about it, for the parabola that faces towards the y-axis. So usually how I would say this is the transverse axis is parallel to the x-axis, or the transverse axis is parallel to the x-axis. That transverse axis is the one that goes through the vertices and the center. Okay, so the foci in this case, we're changing the y value of our point. So we have h comma k plus or minus c. The vertices on the transverse axis okay, so the vertices on the transverse axis so these points right in here, we're adding and subtracting a from the y value of our point from the center. So it would be h comma k plus or minus a. And then the vertices on the conjugate axis so in this case, it's affecting the x value from the center, and we're adding or subtracting our b value from the x value of the center. So h plus or minus b comma k. So before, how I had done this, I had told you, okay, well, when we make this transverse axis and the minor axis, what we're doing is we're creating this box. And so we're going to go out the same length as the transverse axis, the same height as the conjugate axis. And then we're going to draw a diagonal line through the corner in the center. Kind of make this box. And I didn't do a great picture, but the parabola shape is going to be hugging those asymptotes as it goes off to positive and negative infinity. But I just mentioned when the video was off that I haven't given you the formula for the equation of the asymptotes, but you can find those because you're going to be given multiple points, or you can find multiple points. You know what that center is, and you can look at one of the corner points of that box. And we know that we can find the equation of line given 2 points. We could find the slope. And then with that point, we could figure out what that y-intercept is, or use the point slope formula for the equation. Okay, so let's look at some examples. Maybe let's look at one that's already in the standard form and then going about graphing and finding these values. And then we'll look at one that's not in the standard form and putting it into it. The other thing on this is I'm giving you these formulas that work for any center. The same thing with the ellipse and the parabola. I gave you this where the center are the vertices. Was at any center, and I didn't start out with the center being the origin 0, 0. So you should recognize, though, if H and K were 0, what it would look like. Okay, so pulling an example. Let's say we have the following. So y plus 3 quantity squared all over 4 minus x minus 2 quantity squared all over 9 equals 1. So just looking at this, I can tell that my transverse axis, the ones that join my vertices and goes through the center, are is parallel to the y-axis. So that parabola shape is facing towards the y-axis. So I can also tell what my center is. H value is always with the x opposite sign. So it's x minus 2, so my H value is positive 2. My K value of my center is negative 3. A squared is always with the positive. So A squared is 4. A and B are distances, so we're not looking at the negative when we take the square root of both sides. So A is equal to 2. B value is always with a negative. And so my B value, or B squared, is equal to 9. So B is equal to 3. Recall, I told you that C squared, this was equal to A squared plus B squared. So in our case, C squared is equal to 4 plus 9. C squared is equal to 13, or C is equal to square root 13. The directions in here, let me just read the directions just so you get familiar with the directions and what they tell us to do. So it says find the center, transverse axis, vertices, foci, and asymptotes, and graph each equation. Okay. So let's start graphing what we have. We know what the center is. So let's go off of where the center is. So we have a center at 2, negative 3. So going over 2 and down 3. So our A value is 2. So to get to our vertices, we're going to go up and down 2 from the center. So our vertices, up 2. So if we go up 2 from the center, our x value is the same, it's 2, but our y value is negative 1. And if we go down 2 from the center, we're going to have 2, -5. Let's get the vertices on that conjugate axis. So the conjugate axis vertices, I'm going to the left and the right. In this case, are my B value of 3. So, and that's from the center. So if I go over to the left 3, I'm now at -1, -3. And if I go to the right 3, I'm now at 5, -3. So if I make my box, same height and width, and I go through the corners of my boxes. And the center. That's going to be telling me how wide this parabola shape is looking. So we need to find the equations of these asymptotes. Okay, so maybe let's look at the one that's positive first, the line that is increasing from left to right. So our asymptotes. Maybe let's call this y sub 1 here. So we know we have a point, the center, let's just always use the center, 2, -3. And maybe this one right here. So this one right here in this corner, that's where our x value is 5, but our y value is -1. So let's find our slope of the line. So we can do that by the change in my y value. So the change in our y value, let's see, -1 minus a -3, so +3, all over 5 minus 2. So we have 2 over 3, or 2/3. So given a point and the slope, we can find that equation of the asymptote. So let's do that. So looking at the first point and the slope of 2/3, plugging in our values into y equals mx plus b. So our y value is -3 equals our slope of 2/3 times our x value of 2 plus b. So I have -3 equals 4/3 plus b. So I'm going to subtract 4/3 on both sides. I noticed that we're going to have to add some fractions. So let's get a common denominator, which would be 3. So subtracting 4/3 from -9/3. So b for the asymptote. So -9/3 minus 4/3 is -13/3. So our equation of one of the asymptotes is y equals my slope, which is 2/3 x minus b, or plus b, which is a minus -13/3. I'm going to call this y sub 1. So let's look at y sub 2. We can do the exact same thing here. Let's call this one y sub 2. And so again, we have a point, the center, 2, -3. And we need another point that's on that line. So it doesn't matter which corner you choose. So let's just choose this bottom right one. So doing that, that x value is 5. And the y value was -5. So we need the slope. So the change in y, -5 minus a -3, so +3, all over 5 minus 2. -5 plus 3 is -2, all over 5 minus 2, which is 3. Our slope is -2/3. Okay, so we have y, plugging things in to figure out what b is. We have y sub 2 equals, sorry, not y sub 2. I need to plug in my point. Plugging in my point. We have, let's do the first point. We have y is -3. Y is -3 is equal to my slope -2/3 times x, which is 2 plus b. So we have -3 equals -4/3 plus b. So if I get a common denominator, so that's -9/3 plus a 4/3, -9 plus 4 is -5/3. So b is our -5/3. So the other asymptote is y sub 2 equals our slope, which was -2/3 minus 5/3. -2/3 x minus 5/3. Okay, so this parabola shape, or hyperbola, parabola shape though, on each side is hugging these asymptotes. So we could go a little further if we wanted to. And looking at this, I notice I don't have any y-intercepts, but I'm going to have 2 separate x-intercepts, depending on which part of the hyperbola I'm looking at. So I could find that by setting y equals 0, but that didn't ask for the intercepts. It just asked for those particular values and graphing it, which we did. So that's one that's already in that standard form that we could just go ahead and find all that information. But as we saw with parabolas and ellipses, it's not always in that form, and that we might have to manipulate it to be in that form. And we can do so by completing the square. So let me pull another example up. Okay, so our next example, like I said, isn't in that form that we can get all that information. We're going to have to complete the square. Here we have the equation y squared minus x squared minus 4y plus 4x minus 1 equals 0. I can tell without knowing that I'm in the hyperbola section that this is a hyperbola. So you should be able to tell by looking at these equations which type of conic section you're dealing with. You can tell it's a hyperbola if you have an x squared and a y squared. So only parabolas have just one x squared or one y or a y squared, but not both of the variables have a square. Circles have the same number in front of the x squared and the y squared. It has to be the same sign also. Ellipses have the exact same sign in front of x squared and y squared, but not the same number. And ellipses, not ellipses, sorry, hyperbolas. Hyperbolas are opposite sign in front of x squared and y squared. One's positive coefficient, one's a negative coefficient. It doesn't have to be the same number. And so looking at this, I notice that I have a positive y squared minus an x squared, opposite signs. One's positive in front of the square, one's negative. So this has to be, to me, a hyperbola. So first thing that I do is I go through and I group my x terms together, my y terms together, and the constant on the other side.
because we're going to need to complete the square both on the x and the y terms. So rewriting this, we have y squared minus 4y. This is already in the form that I can complete that square because that coefficient in front of the y squared is +1. So let's say plus, we're going to add something in here to make that a perfect square. Just regrouping things. Minus, well, in order to complete the square, I don't want that -1 in front of the x squared. And so we're going to actually factor the negative out of these x terms. So if we pull out a negative from those x terms, then we would have parentheses, x squared minus 4x. And we're going to add something in here to make this a perfect square. Go back in a second and figure out what that is. This is equal to, so add your 1 to both sides to get the constant to the other side. But if we add something to one side, we got to add it to the other. So whatever we're adding to the y terms, let's just figure that out now. So the same number that you would add to give you -4, you're going to square that number, and that's what we're adding. So the same number that we add to get -4 is -2. -2 quantity squared is 4. So I have to add 4 over here. We got to be careful here because technically this number we're adding inside the parentheses has this -1 in front of it. So it's like a multiplying whatever we put inside that parentheses by that -1 out in front. So again, we look at this half of b, so it's -2. The same number that we add to get -4 is -2 plus -2. Square that -2, we get 4. That's what we're adding in here. So it's more like we're subtracting off 4 on the other side. So here's our perfect square. So this is y -2 quantity squared minus x -2 quantity squared is equal to, well, we have 1 plus 4 is 5. 5 minus 4 gives us 1. This is in standard form. Remember, these are ellipses and hyperbolas are already set equal to 1. And so I don't have to divide through by anything. If it helps you though, think of this as a fraction here. So those are both over 1. So looking at it, it's the y piece that's that positive. The minus is in front of the x. So that tells me which direction the hyperbola is facing. It's facing towards the y-axis. It'll look like this shape. My a value is always with a positive, a squared, but these are always, this is the same number, is 1. So a is 1. Same thing, b squared. That one's always in the denominator of the fraction with a negative. That's 1, so b is 1. C squared is equal to a squared plus b squared. So 1 plus 1. So c squared equals 2, or c is equal to square root of 2. Our center, HK, our center H is 2 and K is also 2. Okay, so graphing our center, 2, 2. So we're going to go up and down A to get our vertices. And our length of A is 1. So our vertices here are going to be at 2, 3, and 2, 1. To get the other ones on the conjugate axis, we're going to go to the left and the right one. And so we would get 1, 2, and we would get 3, 2. Let's form our box. And let's find our asymptotes. Here's another thing maybe we can do without, I think we can look at this because these aren't our whole numbers, are integers, that we can see that to get our slope that we're rising 1 and running 1, right? So I can see that my slope for the one that's increasing, let's call that one y sub 1, is equal to 1 over 1, or 1. We have a point, or I can, let's see here that if I go down 1 over 1, that my y-intercept, my b value is 0. So my y sub 1 is equal to that asymptote 1x, or just x, plus 0. And then y sub 2. Okay, so to get y sub 2, if I'm at my center, to get to that point on the corner, I would be going down 1 over 1 to the right. So from here, we know that the slope is -1. Okay, so if we look, we can tell what the y-intercept is here without even doing some of the math. We could go up 1 over 1 to the left. That would show me that my y-intercept is going to fall at 4. So b is 4. So my equation for the asymptote that is decreasing is y sub 2 equals -x plus 4. Okay, so graphing it, you get something that looks like this. And so notice that we have 2 x-intercepts and 1 y-intercept. We didn't look at the foci. If we wanted to find the focus, all we're doing is we're adding and subtracting root 2 from our center. And so our foci, from our center, we would have 2 comma, and then we'll have 2 plus, let's just put 2 plus or minus root 2 in here. So we're able to take that equation that wasn't in that standard form for a hyperbola, put it in that standard form, was able to find and identify those important points and lines and graph it. So it's in this next example, we're given information about the hyperbola and we're asked to find the equation of the hyperbola. So looking at this, we have the center at -3, 1. We have a focus at -3, 6, and a vertex at -3, 4. With any of these that give you information about the graph, plot it first. Plotting it's going to help us know what type of shape it is. Like with ellipse, was it elongated with the x-axis or towards the y-axis? In this case, is that parabola shape of the hyperbola facing towards the x-axis or the y-axis? And we can probably figure that out by graphing it. And so we have a center at -3, positive 1. It's going to the left 3 and up 1. We have a focus at -3, 6. And we have a vertex at -3, 4. Okay, so knowing where my foci is, or one of my focus points, I know which direction my hyperbola shapes are always going towards the foci. So it's going to be going upwards and downwards. So that tells me that that y value is positive. And so I'm looking for y minus k, quantity squared over a squared, minus x minus h, quantity squared over b squared, equals 1. So let's look at what we know so far. We know the center. We know that we're going up A to get to this vertex. So if we're going from positive 1 to 4, that has a distance of 3. So we know that our A value in here is 3, which means that A squared would have to be 9. H is -3, K is 4. The focus is at length C. So C, if I look at that distance from the center up to my focus, that's might give me my length of C. So if I'm going from 1 to 6, I know C is 5. Recall that C squared for a hyperbola is equal to A squared plus B squared. So let's put in the information. C was 5, so C squared is 25 equals A squared, which is 9, plus B squared. Subtract 9, I get B squared is 16. B has to be 4. Although I really don't need that because I want to put it in B squared form. So we have B squared, we have A squared, we have our H and K value. And so now we have that equation. So we have y minus k, so y minus 4, quantity squared all over a squared, which is 9, minus x minus h, so x minus a -3, x plus 3, quantity squared all over b squared, which was 16, is equal to 1. So given the information about the hyperbola, we were able to figure out which direction it was facing and the equation. So let's look at one more and then we'll take a break and maybe move on to a different section. Okay, so again, let's say that we're given information about that hyperbola and we're asked to find the equation. So let's say you have vertices at 1, -3, and at 1, 1. You're also given that you have an asymptote that is y plus 1 is equal to our slope 3/2 all times x minus 1. Okay, so plotting what we have two vertices. We have one at 1, -3. And we have one at 1, 1. And we have this graph. Okay, so again, these vertices of the transverse axis, So that tells me that again, that this is facing up and down. And so it's the y value that's positive, y minus k quantity squared all over a squared minus x minus h quantity squared all over b squared is equal to 1. So let's actually figure out what the center is. Well, the center is the midpoint of the vertices. And we talked about how to find the midpoint earlier in the semester. So we're going to sum the x values, so 1 plus 1, and divide it by 2. Sum the y values, -3 plus 1, and divide it by 2. So the center is going to be at 2 over 2, which is 1, and -3 plus 1, so -2 over 2, which is -1. So we have a point at 1, -1. We know our a value is how much we rise, or in this case, rise or fall from the center. And that distance is 2. So that tells me that my a squared value is 4. Okay. Let's graph this. So I'm looking at this. We can distribute, but I'm also noticing that this is in the point slope formula. And so this is in the form of y minus y sub 1 equals our slope m times x minus x sub 1. So here I can tell that I have a point at -1, 1. So -1, 1 is that point on my asymptote. So if that's the case, then I know that length to get over here has to be my b value. And so my b value in this case is also 2. So b squared is 4. And I think I might have made a mistake. I'm not sure if I know those are vertices of my transverse axis, or maybe they're vertices of my conjugate axis. Would that change things? Would that change anything? It still would be the midpoint. This is what's getting me. This slope is 3/2. So it's like I'm rising 3 and running over 2. And in this case, I'm only, yeah, that would be off in this case. Darn it. So I'm thinking I'm off on something. It's a distance of 2. Let's just look at it. I don't know. Let's put this in the y equals mx plus b form. So we have y plus 1 right now equals 3/2 x minus 3/2. If I subtract 1 on both sides, I get y is equal to 3/2 x minus 1. So minus 2/2, this is minus 5/2. Yeah, so something's off on my graph. Because if I graph this line, I graph that line. Well, negative 5/2, so that's negative 2.5. So that would be a point here. Okay, I wrote down half of the information from one problem and some from another, so that's where I'm going to look at this. I wrote it right. Okay, let's take a break. I'll look at this and I'll come back and explain where my reasoning's off in a minute. Okay, so after looking at this, I noticed where I went wrong. First of all, where I thought I was wrong is that this point right here for the equation of the line that we had found was off because I was thinking that had to be the corner of our box. It's not. And so it's okay. That was right. This is, looking like this. Where I was off was this point right here. So this is y minus y sub 1 is equal to our slope times x minus x sub 1. But if I look at this, I put my y sub 1 value as my x sub 1 value. So my my x sub 1 value, opposite sign in here, that would have been 1. And this would have been negative 1. Which if you look at that, that was our center. That is a point on the line. So that didn't help us any to figure out what B was. And so I was off on my B value. So I need to figure out what B is. And so I was trying to think to myself, how would I do that? Well, we know that it has to be horizontal. That corner has to be horizontal with this Y value, which is negative 3. And so I was thinking if we plug in y is negative 3 here, we could figure out what x is on that graph. And so let's do that. So let's say we want to find b, but let's do y is negative 3 is equal to 3/2 x minus 5/2. So I don't want to deal with these fractions in here. So I'm going to clear the fraction by multiplying both sides of my equation by my common denominator, which would be 2. So multiplying every grouping and term on each side of the equation by 2, I get 2 times negative 3 is negative 6 is equal to, well, 2 times that 3/2 x, the 2's cancel, leaving us with 3x, minus 2 times 5/2, the 2's cancel, leaving us with 5. So we have negative 6 equals 3x minus 5. Let's add 5 to both sides. So we get 3x is equal to negative 1. And so x would have to be then negative 1/3. So that's the x value where this is crossing. So I want to find that distance because that distance in here from positive 1, our x value, to that negative 1/3, that is the b value. So let's look at absolute value. 1 minus a negative 1/3. So if we do that, we get that this is 1 plus 1/3 or 4/3. Let's leave it as a fraction, as 4/3. That tells me that b squared then is 16/9. Okay, so now we have our information that we have our equation of this hyperbola. So we have y minus k. So we have y minus our center. Let's find our center again. Our center was 1, negative 1. And so if we do y minus a -1, so y plus 1 quantity squared all over a squared, that was 4, minus x minus h is 1, so x minus 1 quantity squared all over b squared, which we just found was 16/9, is equal to 1. To me, this is standard form. If you don't like the complex fraction, we can invert multiply by this 16/9. So another way we could write this is y plus 1 quantity squared all over 4 minus 9 times the quantity x minus 1 quantity squared all over 16 equals 1. Okay, so we got now the equation given of that hyperbola given that information. The next thing I just wanted to review and recall is what I had mentioned earlier, that you should be able to look at equations of all the different types of conic sections and be able to determine what the shape is and give information. And so over here we have a list of 8 different equations. And so looking at these, we should be able to go through and be able to tell me what is the conic section that it's talking about. And so if we look at this first one, 67, it has x minus 3 quantity squared all over 4 minus y squared over 25 equals 1. So first of all, that's in that standard form, and it's the standard form of this hyperbola. So I can tell this is a hyperbola because of this minus sign right here. If that was a plus in between, that would have been an ellipse. I also notice that the x value is positive, so I actually know what direction that hyperbola is facing. So my transverse axis is parallel to my x-axis, and it's going to be looking like this. We could go further. We could tell what the center is in that case. The center, right, is 3. There's no k value, 0. We know that A is equal to 2 and B is equal to 5. And we can go on and do more and graph that if we wanted to. But to save time, I just kind of wanted to discuss these a little bit. If I look at 68, so notice 68 right here. Again, I have a minus in between those two fractions. So that clues me in that this is a hyperbola again. The minus is in front of the x grouping. And so that tells me that my parabola shape is facing up and down, or hyperbola shape. Again, I could tell that my center is from here. It's 2, -2. I can say that my A value is 4, my B value is 2. And go on. 69. If I look at this, there's only one variable that's squared, and it's the x. So y is not squared in that equation. So that tells me it's a parabola. And if it's x is squared, then I know it's a parabola facing up or down. So recall, we had something in the form of x minus h quantity squared equals 4a all times y minus k. If this was positive in front, that told us that it was facing either up towards the positive direction, in this case up towards the positive y's. I can tell my vertex hk, so h is 0 in this case, and my k value is 3. Looking at 70, notice that in 70, only the y value is squared. If only the y value is squared and the x isn't squared, again, that clues me in that that's a parabola. But since it's the y value that is squared, it's going to be facing either left or right. This value in here is negative, so it's going towards the negative direction of the y, so it would be going this way. It's in that form, again, that I can tell where my vertex is. The vertex HK, so H is -1, and it's y squared, there's no k value, so that k value is 0. Okay, 71 is not in standard form, but I still can look at that and I can tell what type of conic section it is. I might not be able to tell which direction right now until I put it in standard form. But looking at this, I see that I have both an x squared and a y squared. So that eliminates that it's a parabola. So that means it's either a circle, ellipse, or a hyperbola. Looking at the coefficients in front of the x squared and y squared will tell me which one it is. Those are both positive numbers and they're not the same number. So if it's the same sign in front of x squared and y squared, but not the same number, then it is a ellipse. And so in 71, I know I have an ellipse there. Again, I'd have to put this more in a form that I can tell where the center is and is elongated with the x-axis or y-axis. Is that major axis parallel to the x-axis or y-axis? Again, I just wanted to go through and just make sure that you guys can identify. So let's just do that, continue, and I'm not gonna put those in standard form. But 72, notice we have an x squared plus a 36y squared. So we have an x squared and a y squared term. So it's not a parabola. Both of them are positive coefficients in front of the x squared and y squared. They're not the same number, so it has to be an ellipse. '73. So notice in 73, we have x squared minus 6x minus 8y minus 31 equals 0. Notice there's no y squared term in there. It's just an x squared term. So that clues me in that it's a parabola, and it's the x that's squared. So that tells me that it's a parabola that these are either facing up or down. If I put that in standard form, I would then be able to tell and which way it was facing. For 74, here we have 9x squared minus y squared minus 18x minus 8y minus 88 equals 0. So it has an x squared and a y squared term, not a parabola. Coefficient in front of the x squared is 9, and coefficient in front of the y squared is -1. If they're opposite signs, one's positive, one's a negative coefficient, then it tells me that is a hyperbola. Right now, it's the y value that has the minus in between. And so that tells me that it's probably going to be facing towards the x-axis, but I'm not really sure because when I start to go complete the square, I could be dividing by a negative and that would swap my sign there. So I'm not quite sure, but I know that this is a hyperbola. And that was the last one. Okay, so we just finished all that we're doing on conic sections. So you should be able to, again, look at these equations, identify what type of conic section it is. You should be able to put it in standard form if it's not in standard form, and then be able to identify special points, lines, and graph it.